All right, so let's look at the first question. If you have 3 different shirts and 2 different pants, how many shirt pant combinations can you have? What do you guys think? 6. 3 times 2. Now, if you can't understand why that is, let's look at the possible combinations. So if you have 3 shirts, so let's put the shirts here. You have 1, 2, or 3. So you can choose this shirt, or this shirt. Once you pick a shirt, you're going to pick a pair of pants. From the shirt, so if you pick shirt number 1, you can either pick A or B pants. So then you can pick A or B. Thank you. Okay, and then if you pick shirt number 2, you can also pick A or B pants. If you pick shirt 3, you can also pick A or B pants. So basically you have a total of 6 different combinations. Does that make sense? So this is kind of like how it breaks down. Of course, you don't want to draw this tree diagram every single time. It's going to take you too long. So if event M, like picking a shirt, can happen in M number of ways, and then after that, you do event N meaning picking a pair of pants. And that can happen in N number of ways. Then doing M and then doing N can occur in M times N number of ways. Okay, so when things happen in order, first you do this and then you do this. And then each one has a certain number of ways it could happen. The total number of ways things can happen is just multiplying them together. Okay, so let's try this one. A typical California license plate looks like this. The usual combination is 1 digit of number that is from 0 to 9, followed by 3 letters, and then 3 more digits. So that's how usual California license plate looks like. If the numbers and letters are allowed to repeat, okay, so that's an important part, whether it's going to repeat or not. How many different combinations of license plates are possible? Okay, so let's look at it. How many digits are there on this license plate? No, oh, sorry, that's a bad question. How many spaces are there? 7. Okay, so 1, 2, 3, 4, 5, 6, 7. In the first space, what do we have to have? Is it a number or is it a letter? Number. And how many choices do you have to pick from the numbers? 10. Okay, after you pick the number, you have to choose a letter. How many choices are there? 26. After that, you're going to choose another letter. So how many choices are there?
25.
Okay, so you had to read the question. Are they allowed to repeat? Yes, so how many choices? 26. Okay, obviously it's going to be different if you cannot repeat. Do you have a slip?
No.
Okay, and then after that, you pick another letter, right? So another 26. And then after that, you have a number, so how many choices? 10. And then 10, and then 10. Okay, so now you have the choices for all 7 spaces. What do you do with all these numbers? Yeah, multiply them together. So once you multiply them together, that tells you how many choices you can have in a California license plate. So how many ways can you rearrange the California license plate? Go ahead and use your calculator to figure out the number. Okay, so there are a total of 175,760,000. Okay, so that's how many license plates we can actually have in California. All right, so let's have you try one. In 1966, one type of Maryland license plate had 2 letters followed by 4 digits. How many of this type of license plates were possible? And let's say that it's allowed to repeat. Okay, so go ahead and try it. Okay, so that's going to be 26 times 26 times 10 times 10 times 10 times 10, which is 6,760,000. Okay, I guess back then there was not that many cars, so you didn't need that many license plates. All right, let's try another one. This one has more to do with the video you watch. Okay, so the previous example shows the number of ways you can figure out, combinations of something. This time we're going to talk about how many ways can you rearrange the number of things available. Okay, how many ways can you file 12 folders, one after another, in a drawer? So you have 12 folders. You're going to put them in a drawer. How many ways can you rearrange all 12 folders? So let's think about it. You're going to put 12 folders in the drawer, so that means there are 12 spaces available for these folders, right? Okay, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, so let's think about it. When I get to my first space, I'm going to ask myself, which folder do I want to put in this space? So how many choices do I have? 12. So I'm going to put that folder in there. And then I go to my next spot. And then I ask myself, which folder do I want to put in here? How many choices do I have? 11, because I already put one away, right? I go to my next space. How many choices do I have now? 10. And that's going to continue, right? So 9, 8, 7, 6, 5, 4, 3, 2, 1. And basically, we're going to multiply all the numbers together. So that's a lot of typing on your calculator. Therefore, they invented this button that can do this. So basically, when you're multiplying all the numbers down in successive order, it is basically taking the first number and then you put this exclamation mark sign. That means factorial. Okay, so this is factorial. It's the exclamation mark sign. So you need to find the exclamation mark sign on your calculator so you can use it on the test. Yes, you have a question? Oh, okay. So I'll help. Most of you guys have the TI calculator, like one form of TI or another. I'll just borrow yours. Yours is the most common. Okay. So this kind of calculator is the one that says PRB. PRB says probability. So if you click on that, it's one of the choices in there. There's a factorial sign. Yours is. Okay, so find the factorial button on your calculator. The way you read it is 12 factorial. And that's going to give you the answer instead of typing everything out. Right, so for example, 5 factorial, you type in 5 and then figure out the number. So 5, 4, 3, 2, 1. Or just use the calculator to figure this out. 120. Now there is a special case, 0 factorial. 0 factorial is 1. So you just have to remember that this is a special case, kind of like when you have like 3 to the 0 or anything to the 0 power, we say that's 1. So then there is a rule for this as well. 0 factorial is just 1. Okay, yes?
Why?
I knew somebody's going to ask. Maybe I think I saw an explanation somewhere. It's a little bit tricky, but more so because they just need to have a number there to make sure that factorial works, I guess, in a way. Yeah. Anyways, it's 1. I'm not really sure. I will check and let you guys know. Okay, so let's have you guys practice. 1, 2, 3. Okay, what's 3 factorial? 6. What's 4 factorial? Huh? 24. And then 4 factorial divided by 2 factorial? 12. Okay. Please don't take 4 divided by 2 and then do a factorial. That would be wrong. Do each one individually. Okay, so this is where we get to permutation and combination. If you're given a set of items, you want to figure out the number of ways to arrange them, you'll either use permutation, permutation, or combination. Okay, those are also special buttons on your calculator. Permutation, so, hopefully you watched the video and you're trying to figure out how to use or when to use them. Permutation, order matters. So position matters, P for position. All right. Okay, so the formula is NPR. I think in the video they use K instead of R, but we're just going to use R for both permutation and combination. So NPR. The actual formula is a little bit long, but you do for this test you don't really need to remember it. But on the SAT and things like that, sometimes they will say do it without calculator, or things like that. They will give you this kind of question to you. You do need to remember the formula yourself. Okay, so it's n factorial divided by n minus r factorial. So this is the formula. N factorial divided by n minus r factorial. For example, 5p2. 5p2 is going to be 5 factorial divided by 5 minus 2 factorial. So what you do with the 5 minus 2 factorial is you just do PAMDAS. So you do the parentheses first. So that's going to be 5 factorial divided by 3 factorial. Okay, so let's just do this by hand, and then I'll show you how to do this on the calculator. 5, 4, 3, 2, 1, divided by 3, 2, 1. So 3, 2, 1 is going to cancel. It's just 5 times 4, which is 20. Okay, now let's use the calculator. 5p2. First, locate the P button on your calculator. So if you have the calculator that Brian does, it's in the PRB button. It has all of the probability stuff in there. So every calculator works just a little differently. You may have to enter 5 first, and then P, and then 2, or I'm not really sure how your calculator works. But you should get 20. So somehow try it and then get 20. If you don't know how to use it, let me know. Okay, next, combination. Combination is order doesn't matter. C means choosing. So C in combination means choosing. So we're going to take a small group from a large group. Okay, the formula is NCR. NCR is n factorial divided by n minus r factorial divided by r factorial. So it's very similar to the NPR formula, except it has an additional r factorial that you're dividing. The reason being you don't care about the order, so you actually have less ways for them to rearrange. Okay, so same numbers, 5 and 2, but let's do 5CR. Okay, so that is 5 factorial divided by 5 minus 2 factorial divided by 2 factorial. Okay, so let's take a look. 5, 4, 3, 2, 1. Divided by 5 minus 2 is 3, so that's going to be 3 factorial and then 2 factorial. Okay, so the 3, 2, 1 and 3, 2, 1 cancels again. 5 times 4 divided by 2 times 1, so that is 20 divided by 2. So the answer is 10. Okay, so now find the NCR button on your calculator and make sure that you can get 10. All right, for this, how are you guys feeling about this? Like, 1, 2, 3, 4, 5. 5 is like, I know how to do this. We don't really have to practice this anymore. 1 is like, I probably need a little, I don't understand what's going on. So 1, 2, 3, 4, 5. Yeah. Okay, I'll help you later. So 1, 2, 3, 4, 5. Okay, all right. Okay, let's do one more practice then. Number 2, 7p4. All right, 7p4 is 840. Are you guys good? Easy? Okay, next. Let's actually do the problems. Okay, so you're going to figure out whether you're going to use permutation or combination. So you're going to ask yourself, does position matter? Or if position matters, if this person cannot be the same as that person, then use P, permutation. If you're choosing a small group out of a big group, use C, combination. Okay, so let me do one with you guys, and then you guys are going to pick all the other ones. A chemistry teacher divides his class into 8 groups. Each group submits one drawing of the molecular structure of water. He will select 4 of the drawings to display. And how many different ways can you select the drawing? Okay, so you are going to talk to your partner. You're going to decide, is this permutation or is this combination? Talk to your partner. Permutation or combination? All right, let me give you an example. For example, in this class, let's say that I want to take 5 people to get me lunch because I'm hungry. So does order matter? No, I'm just picking 5 people. Let's say that I want to pick these 5 people, and one person is going to be the person who cleans my fridge, like picking like slaves. One person clean my fridge, one person vacuum my floor, one person to open the door for me every day, one person to greet me when I come out my car, one person to get me coffee. Okay, does position matter? Yeah. Yes, position matters. If I just pick 5 people and say go, do something, position doesn't matter. If every person has a specific role, position matters. Okay, look at the question again. Does position matter? All right, let's vote. Yeah, you have a question.
Okay, never mind.
Okay, let's vote. How many people think position matters, so it's permutation? Okay, how many people think position doesn't matter, so it's combination? It's combination. Okay. Out of the 8 groups, he's just going to select 4. There is no difference between the 4. He's just picking 4 people out of the 8. So position doesn't matter. Okay, so the way you do it is so we're going to use C, right? NCR. Okay, N means the total number. So there are a total number of 8 groups. And R means how many you're choosing. So he's choosing 4. Okay, N is the total. R is how many you choose. So if you remember from the video, it was a little bit strange. So you have was a 10 piece of clothing, you're picking 2 to sell to the black market. So if you're just picking, you didn't pay attention to, you stole something from the store and then you're trying to resell it. No, nobody paid attention to that part.
Did he say black market and then he changed it to glass market? Yeah.
Wait, he changed it to what?
He changed it to blouse market.
Okay, so pick 2 out randomly. That is combination. Okay, next. Oh, yeah. Let's have you work with your partner. So 2, 3, 4. Just pick permutation or combination. We're going to check it together and then solve it, just in case you picked the wrong one. Okay, let's go over these. Number 2, you draw winners from a total of 25 tickets in a raffle. The first ticket wins 100, the second ticket wins 50, and the third ticket wins 10. How many different ways can you draw the 3 winning tickets? How many people think it's permutation, order matters? How many people think it's combination, order doesn't matter? Okay, definitely permutation because the first one is the best prize, right? So that's going to be 25p3. From 25 tickets, you want to pick 3. So use your calculator. Okay, 25p3. What's the answer?
13,800.
Good. Okay, next one. 10 students are in a race. First, second, and third place will win medals. In how many ways can 10 runners finish first, second, and third? No ties allowed. How many people think permutation? How many people think combination? Permutation. Order matters. First place, second place, third place are very different things. So we're not just picking 3 people to go on to the finals or something. Then that doesn't matter. But first place, second place, third place cannot change their places. Third place is not the same as first place, right? So order matters. So that is 10p3. (10p3). What's the answer? 10p3. 720. Good. Last one. How many ways can you cook? How many ways can a cook choose 5 potatoes from a bag of 12 potatoes to make a potato salad? How many people think permutation? The order of the potatoes matter. This one went in first. Okay, how many people think combination? Order doesn't matter. Very good. Okay, 12c5. Okay, 12c5 is what? Good, 792. All right, so this is how many ways can you rearrange things. We're going to use that in the next part, which is probability. What does probability mean? Like the probability of you winning a lottery ticket. The probability of you meeting Justin Bieber or somebody. Huh? What does probability mean? The chance, yeah, the possibility. So basically it's a desired outcome. So what you want over total possible. Because probability is always a chance, right? A chance of what? A chance of what you want over everything that can happen. Okay, a chance of what you want over how many ways it can happen. So there are 2 kinds of probability. One is experimental, which is what actually happens in experiment. And then theoretical is what it should happen in theory. So let me give you a real life example. So on Chinese New Year, our family got together and then we ate dumplings. And then my mom wanted to play a game. So then she made me put some stuff inside the dumpling. So then, like, if you eat the one that has the stuff, you get a red envelope, and then the red envelope has like different amount of money in it. So then there were, I think, 20 dumplings, and then 10 of them had something. So my chance of winning is 50-50, right? Except I was very unlucky. So then I only got 1 red envelope that had $1. So I was very sad. So theoretical probability is 50%. My probability is 1 out of 20. Does that make sense? So the experimental for me was 1 out of 20. In reality, in theory, I should get 10 out of 20, but that didn't happen. Okay, so that's the difference. Okay, so example. Of the 60 vehicles in the teacher's parking lot today, 15 are pickup trucks. What is the experimental probability that the vehicle in the lot is a pickup truck? Okay, here's how you set it up. What do you want? What do you want to pick? Pickup truck. Okay, out of total possible, so just total. Okay, how many pickup trucks are there? 15. How many are there total? 60. So it's 15 out of 60. You can either simplify it into a fraction, a simplified fraction, or you can turn it into a percent. So it's up to you. So you can do 15 divided by 60. And that's going to give you 0.25. You can also leave it in 0.25 if you want. If you do turn into percent, please make sure you, bless you, you write 25%. All right, try the next one. A softball player got a hit in 20 of her last 50 times at bat. Okay. A lot of the probability questions has to do with word problems. So if it's kind of how much of the English language can you grasp? So sometimes it's just your way of reading it is not the way the person wrote this problem intended, then it's going to have a lot of problems. Okay, so the softball player is going to went to bat 50 times, and then she hit 20 of the 50 times. So what is the experimental probability that she will get a hit in her next at-bat? Try it. So what'd you guys get? 40%. 20 out of 50. So that is 40%. All right, good. Next. A jar contains 5 red marbles, 2 green marbles, and 6 blue marbles. What is the probability of P red means probability of getting red? So you want red out of total. How many reds are there? 5. How many total marbles are there? 13. So 5 out of 13, you can change it to a percent if you want. Okay, what is that in percent? 38. The next one's a little bit tricky. Probability of blue or green. What do you want to pick? Blue or green. So is it okay if you get green? Is it okay if you get blue? Yes. So how many blue and green are there total? Okay, yes. So if there's an or, you add them together. Because you can get this one or this one. Okay? So A out of 13. And then go ahead and try the last one on your own, not blue. Okay, the last one is 7 out of 13, so that is 54%. Okay, the last kind. How many people have played cards before? Okay, how many people have not played cards before? Okay, so I'm going to assume everybody knows what's in a card, set of cards. Okay, so let me ask you, card questions are very common, so if you don't play cards, you're kind of at a disadvantage. How many cards are there total? 52. Okay, so these are things you should, if you don't know these facts, so they will assume you know these as facts. If you don't know these as facts, you should write them down. Okay, so there are 52 cards. How many cards are red? Half of them, so that is 26. How many suits are there? 4 suits, 4 different kind of suits, okay? In each suit, how many cards are there? 13. Okay, again, if these are not facts to you, you should write it down. What are the numbers in the cards? 1 through 10, and then what happens after that? Jack, Queen, King. Okay. Well, how many in the suit? So that is like 1 color and 1 symbol. How many face cards are there? Ones with a face. In a whole deck, yes, 12. In 1 suit, 3, right? Jack, Queen, King are the only ones. What are the 4 suits?
Heart, spade, diamond, and clubs.
Okay, so these you also have to know as facts. The first one is called a club. You have to know that clubs are black. Again, these are supposed to be facts. So if you don't know them, you need to know them. Okay, the second one is called a spade. Spade is also black. The third one is a heart, and heart is red. And the last one is a diamond, and diamonds are red. All right, this next problem is tricky, so hopefully we will be okay. Okay, what is the theoretical probability of being dealt exactly 2 sevens in a 5-card hand from a standard 52-card deck? All right.
Does 52 card includes
Jokers? We don't use jokers. If you use jokers, it's 54. Okay, so they're going to give you 5 cards. What's the chance that you, in these 5 cards, you get exactly 2 sevens? If I give you 5 cards from this deck, what's the chance that in these 5 cards, 2 of them are sevens? Okay, well, let's think about it. You have 5 cards, right? What is the chance that, remember, it's what you want out of the total, right? Probability is what you want out of total. What's the chance of you getting a 7 in the first, so the first time someone gives you a card, what's the chance of you getting a 7?
1 out of 52.
No, how many?
4
4 out of 52, because there are 4 sevens, right? There are 4 sevens, and then there are 52 cards total. Let's say you got lucky. You got a 4. You got a 7. What's the chance that you get another 7 the next time?
3 out of 51.
3 out of 51. There is only 51 cards left to choose from, okay? 3 out of 51. After that, you don't want any more 7s, because it says exactly 7, not 2. It says exactly 2 sevens, not 2 or more. If it's 2 or more, it's a different kind of probability. Exactly 2 sevens. So after that, I don't want a 7 anymore. What's the probability of me not getting a 7? How many not 7s are there? 48, right? Anything that's not a 7 is what I want. So 52 minus 4, 48. How many cards are there left? 50. Okay, the next 2 cards, I also don't want 7s. So what's the next probability?
47 over 40.
47 out of 49, and the last one is
46 over 40.
46 out of 48. All right, so I multiply that together. However, this is not it. Okay, this is one possible way it could happen. What if this 7 didn't come out on the first time? It came out on the 4th time, right? So this, right now we're assuming 7, 7, not 7, not 7, not 7, right? What if it didn't happen this way? What if these 2 sevens came out the last 2? Or it was first and last? Or it was 2 and 3? So there's a lot of different ways that 2 sevens can come out of, right? So how many ways can 2 sevens come out of 5 cards? Is that combination or permutation? Combination. How many ways can I choose 2 cards out of 5 cards? Right? How many ways can 2 cards come out of 5 cards? So, therefore, I need to multiply by how many ways can 2 sevens come out of 5 cards? Okay, once you multiply all that together, that is the correct probability. You have 5 cards. The 2 sevens are going to come out anywhere in these 5. So you have to figure out how many ways can these 2 cards come out. Huh? The 5 cards that you have on your hand. They're going to give you 5 cards. Okay, so go ahead and figure that out. So there's a lot of calculation on this one. Okay, did you guys get a number? Oh, in percent. Do you have it in percent? 0.12? 4.12. Yeah. So about 4%. Okay, that's method 1. It's more, logical to think of this way. Method 2 is really what textbooks are going to be written in. So you need to learn this one, especially for next year, because we have a whole chapter on probability, and then you have to use this method. Okay, again, probability is what you want over what is total possible. So we want 2 sevens and 3 not 7, right? 2 cards has to be 7. 3 of them obviously is everything else, no 7s. Out of total ways you can get 5 cards out of 52. Okay, what I want is 2 7s and 3 not 7s. Divided by how many ways can I have 5 cards out of 52? Okay. How many ways can I have 5 cards out of 52 is 52C5. How many ways can I just pick 5 out of 52? That is 52C5. How many ways can I get 2 7s? Well, how many 7s are there? 4. So that is 4C2. How many ways can I get 3 not 7s? Well, how many not 7s are there? 48. So 48C3. Okay, if you multiply that together, you should get 4% as well. Okay, it's the same number, so around 4%. Okay, so let me just do this part again. Total number of ways is total number of ways you can get 5 cards out of 52. So that is 52C5. How many ways can you get 2 7s? Well, what is the total? 4. You want 2. How many ways can you get not 7s? Is 48 cards not 7. You want 3 of them. So 48C3. Okay. All right. The first time you see it, it's a little bit tricky. Hopefully, once we do it a few more times, it will get a little better. I think we only have 1 minute left, right? Okay. So your homework tonight is going to be on both the probability and the combination. And then Friday, when you come back, you'll get your test back.